Dear students, today we study about the phase shift oscillator. It is the another type of oscillator. This phase shift oscillator also produces the sine wave in its output. We know that there are two types of oscillators. One is LC oscillator, another one is RC oscillator. Already we have discussed the LC oscillator, that is Hartley oscillator and Colpit oscillator. The LC oscillator, generally the oscillator consists of the three parts. One is the main part is tank circuit, the second part is feedback network, and the third part is the amplifier. In the case of LC oscillators, the tank circuit consists of inductor coil and capacitor. The phase shift oscillator, it is another type of oscillator, is the RC oscillator. These types of RC oscillators also consist of a tank circuit, a feedback circuit, and an amplifier. This RC type oscillator, the tank circuit consists of resistors and capacitors only. It also consists the feedback network and the amplifier. This RC type, there are two oscillators. One is phase shift oscillator, another one is Wien bridge oscillator. Today, we discuss about the phase shift oscillator. The phase shift oscillator produces the sine waves. How it produces the sine wave? Using the phase shift network. What is phase shift network? It is nothing but a tank circuit which consists of resistors and capacitors. So this tank circuit with resistor and capacitor act as a phase shift network. This network is responsible to produce the sine wave. It shifts the phase in every section and then cumulatively it produces the sine wave, and the sine wave is amplified by the amplifier, and it is called as a phase shift oscillator circuit. Let's see the construction of phase shift oscillator. In the phase shift oscillator, the oscillator consists of the active part. The active part of the phase shift oscillator, the active component, is a transistor amplifier. This transistor amplifier amplifies the input signals. And the another part is the RC phase shift network. R is a resistor, C is the capacitor. The phase shift network consists of the three sections, the three sections of RC sections, the RC network. It produces the phase shift between the input and output voltages, and it produces the resonant frequency F0. The phase shift in each RC section produces 60 degree of phase shift. So this phase shift oscillator consists three RC sections. So each RC section produces 60 degree. So the total phase shift produced by the RC network is 180 degree. So the total phase shift produced by the RC network is 180 degree. This is the circuit of phase shift oscillator. It consists of a RC network. It has three sections. RC is one section. It is the second section RC. It is the third section RC. And it is the feedback part. It gives the part of the voltage to the transistor here and here. And it is the amplifier circuit. This amplifier circuit amplifies the voltage produced, the signal produced here, and gives the output voltage here. Consider the first section. It is the voltage V1, input voltage, and V1 dash is the output voltage. Initially, its phase is 0 degree. The V1, this is in the first section. The voltage V1 leading the output voltage leading the input voltage by 60 degree. See here, 60 degree. So it shifts the phase. The shift between the voltage V1 and V1 dash is 60 degree. So the first RC network produces the phase shift of 60 degree. Again, the next, so the 60 degree leaded and phase shifted voltage V1 dash is act as a input to the second section. So again, this second section consists of the R and C. This again shifts the phase shift, the angle by 60 degree. So the output voltage from second RC network leads the input voltage by the output voltage leads the input voltage by again 60 degree. So total the first phase shift network RC network produces a 60 degree phase shift, and the second RC phase shift network produces a 20. So totally the phase shift is 120 degree. Again, its output voltage is fed to the third RC network as a input. This RC network again phase shifts the 60 degree. So it produces totally 180 degree phase shift. By the first RC section, a 60 degree. By second RC section, again a 60 degree, totally 120 degree. Again the third RC section produces a 60 degree, a totally 180 degree phase shift is produced. So this is fed to the transistor. This transistor also produces 180 degree phase shift. Totally here 180, here 180. So we get 360 degree phase shift, and the output is voltage across here. So this is the amplifier. We know well that it consists of the active element as a transistor. The emitter is bias using emitter resistor Re, and a emitter capacitor is connected parallel to it. As it is a NPN transistor, the negative voltage is given to emitter. Emitter is always be connected forward bias. It is a N-type material, so the negative potential is given here. So we know well that base is the forward bias. It is a P-type material. So a positive voltage is given through the resistor R1 and given to the base. Here a DC voltage and the AC sine wave which combines and amplifies and appears across this collector and the ground. RC is the collector resistor gives the biasing voltage to the connector using the external biasing battery plus VCC. So it is a simple explanation about this circuit. So it produces a sine wave without giving any input signal. So this positive DC voltage is converted into a sine wave AC signal using this RC networks. This three section of RC network. When the circuit is switched on, the oscillator produces the sine wave with the resonant frequency of naught. Here we see with a single section, the V1 dash is the output voltage, V1 is the input voltage. The V1 dash is the voltage across the resistor, which leads the input voltage V1 applied here by phase angle phi. If the resistance value, the leading is depends upon the value of the resistor. If the value of the resistor reduced to 0, automatically the output voltage V1 dash leads the input voltage V1 by 90 degree. So phase shift angle phi naught is equal to 90 degree if the resistance value is equal to 0. Now we are adjusting the value of the resistor R so that this output produces the V1 dash is leads the input voltage by 60 degree, not 90 degree. So the value of resistor is adjusted so that the output voltage V1 dash leads the input voltage V1 by 60 degree only in single section. So this V1 dash leads 60 degree from this voltage V1. So it leads 60 degree, not 90 degree. How it leads 60 degree only? Depending upon the value of the resistor R. So in each section it produces 60 degree, 60 degree, 60 degree phase shift and produces 180 degree phase shift wave. So the output E out of the amplifier is again fed back to the RC feedback network. The network produces a phase shift of 180 degree and the voltage appears EI in its output. The voltage is applied to the transfer amplifier again. It amplifies and gives the output. The feedback applied will be also calculated as the input voltage divided by output voltage. When the feedback is in correct phase, as the transistor amplifier is constructed in the common emitter configuration, this transistor amplifier produces again a 180 degree phase shift. The phase shift produced by the network is again 180 degree. So total phase shift in the entire loop is 360 degree or 0 degree. The frequency of oscillation, the frequency of this phase shift oscillator is calculated as Fr is equal to 1 by 2 by Rc into root of 2n. We know Fr is the frequency of the oscillator. It's calculated in hertz. It has three sections. So the R1, R2, R3 value is taken as R. The three sections have equal values of R and equal values of C. So R and C. The three section resistance are taken as RRR and CCC. And what is N? N is the number of the RC feedback stages used to construct a RC network in the phase shift oscillator. So it has three sections. So we substitute 3. So we get root 6. This frequency at which the phase shift circuit oscillates is calculated using this. So as it has three sections, so we get the final formula. Fr is equal to 1 by 2 by RC root 6 here. So what are the advantages of this circuit, the phase shift oscillator? This oscillator does not require transformers or inductors. It can use to produce even very low frequencies. This phase shift oscillator circuit provides a good frequency stability. It has some disadvantages also. Initiating the oscillation is very difficult, as the feedback given to this amplifier is very small and the amplitude of the output produced is also very small. So today we have discussed the construction of phase shift oscillator and working of phase shift oscillator, how it generates the sine wave, how the RC network shifts the output voltage, how the output voltage leads the input voltage, how the value of the resistor changes to lead the voltage, and what are its advantages and disadvantages. It is a simple discussion about the phase shift oscillator. Thank you.